Hello there. A question on transformers. The question reads, a simple transformer has 20 turns in the primary coil and 80 in the secondary coil. A. If 4 volts is supplied, what output voltage is expected? Take conditions to be ideal. So I'll use the transformer equation, just part of it, to simply help me solve the question. So I'll say number of turns over number of turns, therefore in the primary over secondary. Since I've written primary here, then even my voltage is going to be voltage in the primary over voltage in the secondary. If I had begun with number of turns in the secondary here, even voltage would have been secondary there, but current is always the opposite of the two. I think we did that in the previous question, in the previous videos on transformers. So I'm told in the question to say 4 volts is supplied, then the number of turns in the primary is 20, secondary is 80. So I'll say number of turns in the primary is 20, secondary is 80, equal to primary voltage is 4 over secondary voltage. Then I cross multiply there. So I'm going to say 80 times 4, which will give me 320. 4 times 80, 320. 20 times V is equals to be 20 Vs. Then I divide by 20 to make voltage in the secondary the subject. So this one divides. Then I'm going to say voltage in the secondary is going to be 16 volts. Are we looking for voltage in the secondary? Yes, voltage in the secondary. Let me just do my calculations here. Am I just 320 divided by 20 is equals to be 16? Yeah, I'm correct. 16, I'm correct. Number B, the question says if efficiency is 93, calculate power output given primary current. Remember from the other videos, primary current is 1.2. So I'll use the equation that involves the equation for efficiency. So we're going to say efficiency is equals to power output over power input. This is power in the secondary, power in the primary, or power output over power input times 100. That's the equation. But we've been given the efficiency to be 93. So we're going to, this 100 is going to cancel out because I already have this. But if I was solving for efficiency, I would have maintained this expression. Then I should have these two, then multiplied by that. Then I'll find this. Now since I have this 100 cancels out. So I'm going to say 93% is equals to power output over power input. In the question I'm told to say the current in the primary is this, then the voltage in the primary is 4. So I can find the power in the primary circuit or primary coil. Power is equals to voltage times current. Therefore voltage is 4 times 1.2, which is my current. So I'm going to say 4 times 1.2 gives me 4.8 watts. That's power in the primary, which is power in the input, because the primary is a circuit where electricity enters the secondary, the transformer from. So I'm going to have 93 over 100 is equals to power output over 4.8 watts. This 93 over 100 comes about because this is 93%. Cent is a prefix that represents 100. Therefore 93 per 100, or 93 out of 100, 93 per 100, 93 out of 100. So this is how it is actually supposed to be written, as a fraction. So I'll simply resolve this fraction, then multiply by that. So it gives me 93 over 100 gives me 0.93, then times, because I'm cross multiplying. Okay, let me just do step by step. 93 is going to be power output over 4.8 watts. Then if I have to cross multiply, understand that this is over 1, because any number over 1 is actually that same number. So when I cross multiply, power output is going to be times 1, which gives me power output. Then 4.8 times let's say times 0.93 gives me 4.46 watts. That is the power output of this transformer you can tell that the power input is higher than the power output. Therefore, there are some energy losses in this transformer, which is normal in reality. If the transformer is ideal, then the power output will be equal to the power input. It should have given me 4.8 as well, even in the output circuit. So number C there states, state one way of improving transformer efficiency. There are a number of ways of improving transformer efficiency, but one of them is have a good core design. The iron core, of course, have a good iron core design, which will prevent, or which will reduce actually, the loss of the magnetic field. Okay, you really have to utilize all the magnetic energy or magnetic field produced in the transformer to simply help you produce or make the transformer efficient in the production or generation of current in the secondary coil. So a good core design actually reduces loss of the magnetic field. Then the last question is, what type of transformer is this? So D type of transformer. Have a look at the input voltage and the output voltage. The input voltage in this transformer is 4, and then we are told to calculate the output voltage in the secondary coil. So in our calculations, output voltage was Vs, and it is found to be 16. Input is 4, output is 16. This is a step-up transformer. This is where we end for today. Hopefully this video was helpful. If you need me to solve anything about transformers, leave your comments below, or leave your comments below and give me direction on what you would want me to solve. Good day.